Example 8. Find the critical numbers and intervals where the function is increasing and decreasing. So in this case, we have a function that has a domain restriction. The domain must exclude -1. Because -1 would make a zero denominator. We must keep that in mind when we start naming our critical numbers. We take our derivative by using the quotient rule. Remember, denominator, derivative of the numerator, minus numerator, derivative of the denominator, over the denominator squared. So if we've got denominator, x plus 1, derivative of the numerator, 1, minus the numerator, x plus 9, times the derivative of the denominator, which is also 1. And all of that will be over x plus 1 quantity squared. Multiplying out the numerator, x plus 1 minus x minus 9. Now be really careful here. You've got to distribute this minus sign and this 1. The 1 is not going to change anything, but the sign is going to change both signs. This is going to be over x plus 1 quantity squared. So when we simplify this numerator, we get -8 divided by x plus 1 quantity squared, which we could multiply out. -8 over x squared plus 2x plus 1. Use the full rule to do that. So this is my derivative, f prime of x. Now, we're supposed to set our derivative equal to 0, but this derivative is never 0. Because in order for a fraction to be 0, the numerator would have to be 0. But it can never be 0 in this case because it's always -8. So we have no critical numbers. However, we do have a value which makes the derivative undefined and the original function undefined, and that is x equals -1. Remember, x equals -1 is excluded from the domain of the original, and it's actually excluded from this derivative as well, because if you factor this or leave it in the factored form, x plus 1, x plus 1, x plus 1 equals 0 if x is equal to -1. So what I've got to do here is I've got to go ahead and put this value that makes the original function undefined on my number line. And although -1 is not a critical number, it does divide our number line into two regions because the function doesn't even exist at -1. We need to test to see what's happening on the left of -1 and to the right of -1. So we go to our derivative and we put in, let's say we put in a -5 and we put in a 0. So I'm going to test, my test point is -5, my test point is 0. So I'm going to put in -5, and that's going to give me -8 divided by -5 squared plus 2 times -5 plus 1. -8 divided by 25 minus 10 plus 1 is -8 over 16, and that's a negative. And then I put in 0 into my derivative. I get -8 divided by 0 squared plus 2 times 0 plus 1. That's negative 8 over 1, which is also negative. So what this means is that this function has a derivative that's negative to the left of negative 1 and negative to the right of negative 1. So this function is always decreasing except at negative 1 where the function doesn't exist. So we have to exclude that negative 1. So we'll say it's decreasing from negative infinity to negative 1, and again from negative 1 to positive infinity. We must skip over the negative 1 because it's not in the domain of f of x. So it can never be included in any description of increasing or decreasing.